Hey everybody, welcome to the pre-show. Thanks for joining us a little bit early if you're here with us. As usual, we're going to be talking a little bit about the week in cyber news before we get into today's Python stuff. This was a pretty interesting week for cyber news. The second week of the month often is an interesting week for cyber news, and that would be because the second Tuesday of every month is Patch Tuesday for Microsoft. So that is when Microsoft releases its updates for Windows. And there always tends to be something a little bit interesting inside of that bundle of updates. And this month was no exception. So inside of this month's updates, Microsoft disclosed two zero-day vulnerabilities. What are zero-day vulnerabilities? 0 days are vulnerabilities that you have no days, 0 days to defend against. And that's because they're already being used by the bad guys, by cyber criminals, to attack systems in the wild, as we say. So meaning that Microsoft or some other entity has observed an attack using these specific vulnerabilities. When that's true, when an attack has been observed using the vulnerability in the wild, then you have no days to defend against it. It's called a 0 day. There are other really severe vulnerabilities, but that specific term 0 day is about the fact that you have no time to defend against it. So there were two in this month's updates. The first was in Internet Explorer, which is a little bit scary because when you have a vulnerability in a web browser, that tends to mean that the exploit, the attack, can be carried out remotely, right, over a malicious website or something like that. So that means that you have a really wide attack surface area. And this the Internet Explorer vulnerability in particular was used in an attack called Operation Powerfall. Great. So it's always a good sign when you have a cool sounding name for a cyber attack. Now, when we talk about vulnerabilities, we talk about their severity. And when we do that, we use a couple of things. The first thing to know is that when we refer to vulnerabilities, often they'll have cool names like Eternal Blue or SMB Ghost or whatever. And that's just because we're nerds. We're really lame and we need to come up with cool names for things. Man, there have been some good ones. Heartbleed, Curveball. Anyway, more formally, vulnerabilities are assigned a CVE number or a common vulnerability and exceptions number. And they kind of go by CVE dash and then the year of their disclosure and then whatever number in the sequence they have. So, for example, this Internet Explorer 0 day was given CVE 2020-0986. And you can look these up. If you Google for that number or just for CVEs in general, you'll be taken to the National Vulnerability Database, NVD, which is maintained by the National Institute for Standards and Technology, or NIST. So, worth taking a look at these. It's kind of cool, and it's always a fun claim when a security researcher can earn a CVE. That's a goal for me personally at some point in my career. Haven't done it yet and probably won't for a while, but it would be cool to do. There was another non-0 day vulnerability in the Windows updates this month that was kind of cool, which was Windows tried to patch this vulnerability before but didn't do it properly. And so there was a way that an attacker could create a fake printer, and that fake printer could print out sensitive files with like full admin access on the device. So that was a pretty cool vulnerability to take a look at as well. Vulnerabilities, CVEs, are assigned a CVSS score, or a common vulnerability scoring system score. A little redundant, but that's what it's called. So the scale goes from 0 to 10, 10 being absolutely critical, DEFCON 1, batten down the hatches. And the 0 days this month were not CVSS 10. We've had a few others that were pretty severe, other vulnerabilities this month that were, but the severity is the result of an equation about the ease of attack, the attack vector, a few other criteria that go into calculating the score. But so when we talk about vulnerabilities, we'll use the CVE number and we'll use the severity score often as just kind of as a metric, an easy heuristic to understand how bad something is. They're not the only ways to talk about vulnerabilities, but they can be helpful. There was another really interesting story this week related to the SANS data breach. Now, SANS, if you're not familiar, is an enterprise leading, an industry leading trainer for cybersecurity. SANS courses are crazy expensive, and that's because they're hoping that your company will pay for the tuition rather than individuals. And their training is widely considered kind of best in class, right? So for threat hunting, digital forensics, penetration testing, all the sort of cybersecurity skill sets, that's kind of what SANS teaches, and their instructors are some of the best in the field. Folks like Jake Williams, and I don't know, they're admirable. And so it was kind of interesting to see that this week SANS suffered a data breach. They had customer information disclosed as the result of a phishing attack. And this phishing attack was not particularly complex. It's the same kind of phishing attack that any other organization might fall victim to. And, you know, they just released some details about the attack yesterday. And bottom line, somebody in their organization was given a malicious Office document. Now, Office documents are a very popular attack vector because Microsoft Office documents can embed code inside of them using a language called Visual Basic. And Visual Basic can execute code, download items, right? And if you have macros enabled for your Office documents, that code can execute, and you can compromise your own computer by opening up spreadsheets and Word documents or PowerPoints, right? Stuff that you might expect to get during the normal flow of business. But if you open one up from even a trusted source, and you have this malicious code in there, they got you. And that's exactly what happened here. Interestingly, we talked last week about the Emotet botnet, and Emotet is using exactly this this attack vector as well to spread, right? So they'll also take a look at your email and reply to conversations in progress and attach a malicious file to that reply. And it looks like a part of a conversation you're having, so you trust it. You open the document and they got you. So just kind of interesting to see these. It doesn't matter how technically proficient you are. Humans are humans, and we can all fall victim to these same kinds of simple attacks. It's very difficult to be constantly vigilant, and that's why, you know, the attackers have the easy job. The defenders have the hard job. The attackers only have to get it right once. The defenders have to get it right every single time. It's just kind of a cool way to think about the threat landscape and what the professionals in cybersecurity are really up against. All right. Looks like we're about at 10 o'clock, so let's get this started. Welcome everybody to Hack Summer. My name is Taggart. You can follow me at on Twitter there. If it's not too much trouble, I would really appreciate a like for this video and a subscription to the channel if you're liking what we're doing here. It helps me out. It helps other people find this content so that they can learn Python and cybersecurity right along with us. So that's what we're doing. We are looking at Python, and we're looking at Python through the lens of cybersecurity, and vice versa, looking at cybersecurity through the lens of Python. So last time we dove pretty deep into a core concept in Python programming, which was classes and object-oriented programming. And we took quite some time to rebuild our rock, paper, scissors game to use classes rather than just raw functions. We're going to take a step back today to talk a little bit more about the process of learning Python and how to progress once we get to this particular spot. This is usually the part of the learning experience for new programmers where students of all ages really start to feel lost. Why do they start to feel lost? I call it the should syndrome. So wherever you came from when you're starting your programming journey, maybe you've already learned another programming language and you're just learning Python. Maybe this is your first programming language, and that's kind of where I'm going to focus the conversation. But maybe you've been working in tech, maybe not. You have some expectations of yourself and you have some assumptions about how this is supposed to go. Whether you know you do or not, you do, right? You have some ideas about what learning to program is going to look and feel like as you go. And often, especially if you're really struggling with some concepts early on, which, by the way, everybody does, you get into this headspace of like, well, I should just be able to do this. I should be able to just make this happen. It should be easy for me by now. I must just be bad at programming. And I will also say that often I find happens in students who had bad teachers. School does a number on us. Especially I think that math teachers in particular, I'm not trying to ding math teachers, but I think math teachers have a really hard time because there is this concept out there of like bad at math, right? Where students get it into their head that they just can't do it. That's not a thing. What is a thing is that sometimes people learn at different rates and they develop different abilities at different times. And they also understand things in different ways that sometimes teachers are not equipped to provide to those students. All of that is okay. So if you're experiencing should syndrome right now, if you're feeling a little bit like, you're falling behind in your own expectations of yourself, first of all, ask yourself, who told you where you should be by now? Was it you? If so, you're not an authoritative source on where you should be because you're still learning. So, go a little bit easier on yourself on that one. It's okay to take the time that you need to take to learn this stuff. If it was somebody else, they can shut up. Gatekeeping is a problem with learning programming. It just is. People who have worked hard to learn the skill, mostly dudes, tend to get defensive about their experience and other people learning it, and they like to feel superior to others as they're learning. It's pretty gross, it's pretty toxic, and if you've experienced that, I'm really sorry. But I wanted to take a moment to call it out. If somebody's telling you that you're not good enough to do it, or if somebody's telling you that by this point you should be able to do X, Y, or Z, they are spouting nonsense. They're full of it. Take the time that you need. It's okay to learn at your pace. And I will also say that people who think that they're really, really fast learners, or think that they are extremely talented because they were fast, talent and speed are not the same thing, and understanding and speed are not the same thing. And I've often found that the students who really work at a more methodical pace, right, taking their time to understand every bit and piece of the topic, those are the students who really understand the concept deeply, rather than the folks who can, speed away and get the right answer. So be kind to yourself as we're going through that. But this is the point in learning where we've gone through some of the material, and you might feel like, okay, well, we've gone over these programming basics. We've kind of walked together through some programming exercises. We built a program together. I should be able to do this on my own now. No, that's not how it works. I will tell you that a lot of my philosophy of teaching comes from physical skills and semi-physical skills. So I liken learning programming to learning a musical instrument, or also learning martial arts. Those are two things that I've done in my past that I really enjoyed and I'm passionate about. And they both felt very similar to how it feels to learn programming. Now, when you start to learn a musical instrument, the first thing you do is you're learning, for example, on the piano, you're learning scales, right? And you're learning how to read music, and you are playing the music of others, right? You're playing pieces that other people have written, and you're doing so under the close watchful eye of your teacher. And they're not telling you to go off and make your own music right away, usually, right? You're learning, you're kind of mimicking how other people have produced music. That's what you do first. Similarly, in martial arts, in traditional martial arts like kung fu or karate, you're not inventing new kata or forms right away, right? You're not inventing new techniques. You are learning techniques that others have created. How do you do it? You start by mimicking others, right? You learn the stances, you learn the motions, and you might not understand at the beginning why all of the things matter. And you're told to follow along for a little bit. Then, as the muscle memory of those movements become ingrained in you so that you no longer have to think about that's no longer what we call active or germane load for what you have to think about, then you're in a place where you can really start to understand other concepts, deeper concepts, and take those base understandings that are now muscle memory essentially, and apply them to your own creations. So you become a proficient enough programmer, you can write your own programs. You become a proficient enough musician, you can improvise your own music or write your own music. You become a proficient enough martial artist, you can spar, right? You can apply those techniques in real time, and come up with new concepts of your own that make sense. That is where you are right now. You are in that creating muscle memory phase, and it's not the most intellectual thing, honestly, right? We're not in a lit theory class, or we're not in an analytical calculus class, right? It's not that yet. It is very core. We're getting the patterns down. We're getting the patterns ingrained in us so deeply that later they will be automatic, so we can think about other things. Okay, so in this space, then, how do we progress if we're in that spot? This is difficult remote, right? If we were all in a classroom together, we would all have exercises we could do together, and that conversation would be really important. And if you ever do have questions, even if you're not watching this live, right, please, drop me a line on Twitter. I'm happy to respond to any questions that students have. I'm doing this to help people learn. But how do we do this remotely? How do you practice on your own? How do you build up that muscle memory? So today I'm going to show you a bunch of techniques that I have used, a lot of resources that I have used to build up that muscle memory and really go from an okay programmer to a really solid programmer, because of the way that these exercises force you to think about programming and how you're going to see the work of others as you progress. So let's get started. Let's get started with the first resource that I wanted to share with you today. Okay, so the first resource that I wanted to share with you is a site called Code Wars. Some of you may have heard of it before. I love Code Wars, and I love it because it does a couple of things. We'll go through how it works. We'll kind of do a few exercises in Code Wars. And by the way, I'm doing this live, so if I struggle with one or two of them, that's how it goes. But Code Wars gives you these things called kata, very much like martial arts, right? And they're small training exercises that focus on one programming concept at a time. And you write the code to kind of pass the test that the exercise provides. And then when you're finished, you're able to see the answers of others. And that's really where the value is here in Code Wars, as far as I'm concerned, is that as you progress, you see how other people have solved the problem, and you learn a little bit more about the language as you do. So here I am. I'm not logged in because I wanted to go through the account process with you. And you see here at the home screen, it says, to join, you must first prove your skills. Choose your language to begin. So you can see there are a lot of different programming languages, but there is our friendly noodle over here. There's Python. So let's go ahead and click on Python. And the first thing that it asks you to do, this is before you even create an account, right? It's asking you to to demonstrate some understanding of programming. So this code does not execute properly. Try to figure out why. So let's see. We have a function multiply that takes two arguments, a and b, and it is doing a times b, so it's a little silly as a function, but the code syntax is correct. But if it's not executing properly, why might that be? Why might that be? My supposition is because the function should be returning a value, and right now it's not because it's missing the return keyword. So I'm going to go ahead and put in that return keyword and hit submit. Cool, I was right. And you can see that the tests were passed, and then it's going to ask me to sign in. Now, you can sign up with an email address and a username and password, or you can sign up with a GitHub account. And we haven't talked about GitHub yet on this in this series, but you should have a GitHub account. Even if you're not using it yet, take this opportunity to go sign up for a GitHub account. We'll talk more about GitHub in later in later videos, but it's worth having. It's kind of the social media of programmers, but it's also a place to store and explore code projects. So my recommendation to you would be to sign up for a GitHub account and then link the GitHub account, like so. Okay, and I'm going to go ahead and put in, feel free to email me here. I know that it's not great OPSEC, but there you go. Okay, so here we are, we're set up in our account, and as you can see, there are a bunch of different languages that we can learn from. And you can set up your preferences here. So what is your programming experience? You would set up learning to program. I'm going to go ahead and set up like senior dev, and you would like to receive our newsletter. No more email, please. And then choose the languages you wish to train. I'm going to choose a couple now to tell you the languages that I like, but we're going to do Python. So I love me some Haskell. Also Clojure is okay. F# is cool. These are functional programming languages. Let's also throw Go in there. That's a pretty important one. Obviously, so Python was already selected, as you can see. JavaScript for the web, and I'll toss in Rust as well. It's kind of an eclectic mix of languages, and you can throw in their shell, right? Bash, which we've played a little bit with. Anything that's interesting to you, right? You don't have to, and you can choose others later. These are just sort of your starting preferences. Okay. Now, your home page is going to look kind of like this, and I'll zoom this in just a little bit so it's easier to read. But it looks a little bit like this, where you're going to be given a random challenge, and then you can either train or skip it, and you can change your language, right? But what we're going to do is we're actually going to go over to the kata section to manually choose the kata that we're going to start with. And you can do sort by difficulty, and the difficulties descend. So 8Q is the easiest. So I'm going to choose Python as my language, and we'll start with the easiest, right? 8Q. And just to get us familiar with how Code Wars works, let's do the Hello World exercise. So we'll click on that exercise, and it tells us a little bit about what we're going to be doing. Define a method hello that returns, important word, hello name to a given name. Very similar to what we've done before, but let's see how we train this in Code Wars. So we go ahead and click train. And we get some pop-ups here. I don't usually read these because we're going to go through this ourselves. So this is a really cool example of what's called test-driven development, or TDD. because if you look up at the top, there's your solution, right? And this is the thing this is where we have to write our code. But at the bottom, this is the test. These are the sample tests that you have to pass. And you can kind of read it. You know, we've done enough Python where you can kind of understand what's going on here, where we have the tests where if we give the function the name John, it should return hello, comma, space, John, right? We see that if we give it this weirdly capitalized Alice, we should get a properly capitalized Alice, right? That's really handy to know. And then it's going to run all the tests and see how it does. So let's go ahead and try to solve this one. So we know that we're getting the string called name coming into this function, and we know that we have to do kind of a hello. We have to do some string concatenation here. Okay, so let's do it the easy way first, right? We can do like return hello, comma, space, plus name, plus exclamation point. That's the easy way to do it. Let's see how that works. So we'll go ahead and click on test. And so we got some tests passed, but some failed, right? Where it says hello Alice should equal hello Alice. So it kind of looks like we should be doing something to that string to normalize it, right? And we also failed another test where hello nothing should equal hello world. And there are a couple of ways of doing this. So we have to account for the possibility that giving it nothing right here results in world. So lots of different ways we can work with this one, but let's get started first. Let's see if we can fix this problem here, the capitalization problem. Let's try to use some of the built-in methods of Python strings to help us. So we can go over to Python docs, right? We can go to library reference and check out strings. And let's go find capitalize. So it tells us here that capitalize is a method on strings that returns a copy of the string with its first character capitalized and the rest lowercase. That is exactly what we want. So let's go ahead and take name and actually use the capitalize method and use that in our string rather than raw name. Okay, let's go ahead and test that again. Hopefully we pass the Alice test. Okay, we passed the Alice test. That's good news, but we're not passing the empty test. Okay, so this is funny because if it had been like, if they had given us none, yes, you can mess with the tests, but you shouldn't do that. Don't be Kirk in the Kobayashi Maru. Leave the tests alone. If it had given us none rather than the empty string, we could do this thing called default parameters. We haven't talked about that yet in functions, but you can provide defaults in the function parameters to Python functions so that if it isn't provided, you can just say like name equals world, like that. And so if it isn't given anything, it will default to this string, but it is giving us something. It is giving us an empty string, so we have to account for that. So what we can do is we can overload or override the name parameter here and say name, we'll do this. If name, if the length of name is greater than 0, name equals name, else name equals world. This is a totally valid way to do it. There is actually a shorter way to do this, but this works for now. So we're taking this name, right, and we're kind of reassigning it if yeah, that's right. So if the length of the name is greater than 0, we're going to leave well enough alone, right? Otherwise, name equals world. Now we could shorten this, of course, by saying if the length of name is equal to 0, then we just do the name equals world, right? We don't even need the else. See how we change our thinking about that? We don't even have to worry about that. And let's run this test and see how that does. Okay, we passed 3 tests. And these were kind of the sample. We're not actually doing the whole test suite. We're just doing our sample tests. Now, if we're ready to submit our solution, we go ahead and click Attempt, and that will run all of the tests. Did I click Test or Attempt? So we passed the basic tests, but then we got this error. Check this out, where it says that hello is missing one positional argument name. And so there is, in the full test suite, there is one where they don't include the argument name, that they're just calling hello without a parameter. So we are going to use that default parameter trick to put world in here. Let's try that again. Okay, so it passed all of the tests. Now this is where the best part happens, right? Once you pass all the tests, now you submit your answer, and then you get to see how other people solved it. Now, the solution, there is no right or wrong here, right? There are arguments to be made for different approaches to the solution. Now you can see that this one here is very, very clean in that it's short, right? Where we use an empty string as the default, and then it's doing this dot title and then an or world. So if it's empty, it defaults to this. Now this is considered the cleverest, and notice that each of these, you can vote on these too, right? If this looks like a best practice to you, or if it's clever, and then you can fork it, you can retrain and try their code out. But one of the things that's a little bit interesting here is it's using the F string. This is the shortcut for the format that we've done before. We haven't done it yet just because we were building up to it. And also, hey, dot title, we didn't use that. So what is that about? Let's check it out. So it's very similar to capitalize, right? But if there's more than one name or more than one word in the string, it's going to capitalize the beginning of every word. But as you scroll down, you can see there are lots of different approaches here. So it's really worth taking a look at how this goes and learning from how other people have solved it. And you might think, okay, well, how do I know which solution is the best? That's kind of like asking, what's the best writing style? Because there are styles in programming. I like to strike a balance between readability and efficiency. So I actually really like this one. This one's nice. But notice that it's using a cool Python trick where you're one-lining your conditional. We haven't talked about how to do this yet, but you can do one-line conditionals if they're short like this. This one's interesting too. It's using a different form of string formatting that we haven't talked about. This one is crazy. It works, but it's using this is a very functional programming approach to using Python. So it's almost like using Python against itself. So it looks cool, but I don't know if I would provide code in like a real program this way. But it just goes to show you that there's many ways to arrive at the same solution. Let's take a look at another one, and then we'll move on. Okay. Let's do let's try returning strings. Let's see how that goes. It's the same one. that's no good. Let's try simple. It's 8. Let's look for some more EQ just to stay at easy mode for just a minute. Oh, this is a good one. So function syntax debugging. Let's take a look at this then. A student was working on a function and made some syntax mistakes while coding. Help them find their mistakes and fix them. This is actually a great exercise, and I highly recommend doing this. So here's a fun one. So if you have working code that you've written, right? Give it to somebody else and have them delete random stuff from your code. Like just, characters like colons or unindent something, right? Have them break your code and then give it back to you and see if you can figure out how to repair it. Really, really fun way to learn how to debug. So let's go ahead and train on this one and see if we can identify what went wrong. Okay. Made some syntax mistakes while coding, help them find their mistake and fix them. So the function is called main, and it looks like, based on the tests, that it takes a verb and a noun, right? Take item, and it should return the verb plus a space, importantly, and the noun. Okay, so take a look at what they've written and see if you can identify the syntax errors. Okay. First off, we know that functions need parentheses, not square brackets. So this should say verb, comma, noun. That's one. And we also know that function definitions have to end in a colon, and then anything inside has to be indented. So before we had done that, the code wouldn't even have run at all. Regardless of what it was outputting, it wouldn't have run at all. Now it will run. So let's try to test it and see what we get back. Okay. See, they're kind of gaming the system for us. See how they're adding the space? I expected that to fail. See how they're adding the space to the first verb or to the first argument? So that we don't have to worry about the space. That's very kind of them. But, okay, so if we run the attempt, we should be able to pass this one with flying colors. Yep. Yeah, they should all pretty much look the same. Look. So even here, you can see you can do things in crazy ways. Like so. Which is a fun way to learn interesting things about the language, right? But by far, this is the way that is most accepted. All right, let's try another one. Let's go a little bit harder. Yeah, we'll go for simple directions reversal. Boy, I really hope I'm not biting off more than I can chew here. Hopefully not. In this kata, you will be given directions and your task will be to find your way back. Oh, interesting. This one's really interesting. Let's give it a shot. Okay, so the idea is that we are given a list. I'm going to change this to the word LST, or the argument LST, because we call them lists, not arrays in Python. So we're given a list of directions, right? And it says like begin, and then right, and then left, right? And so what we have to do, first of all, is we have to reverse the order of the directions, right? So if we've arrived on 9th drive, we're actually beginning on 9th drive. And then we have to reverse all the directions. Huh? So this is fun. So there are several steps that we have to do here. Let's break them down. And this is a really good example of breaking down complex solutions into smaller pieces. So the first thing we know we need to do is reverse the order of the directions. And if you remember, let me fire up a replit real quick so we can play. If you remember, just going to make a quick list of 3 integers. If you remember, if we use the indexing to step by -1, we can get it that way. We can also do reverse, I think. Is it reversed? Yeah, I don't like doing it that way. That will actually work, but I prefer to do the slicing this way. So we're saying start at the beginning of the list and go throughout the entire list, and then increment by steps of -1, which walks backwards through the list. So we know how to reverse the list. So that's step 1. Okay, so we'll call it rev equals lst -1. Cool. And then what do we have to do? We have to do some replacements. Turns out that strings have a replace method built right in. So if I were to, let's go over to my REPL again. So if I say like begin on 3rd Street dot replace begin end, it's going to take that piece of the string and replace it with the new string that I give it. All right, so what are the things that we need to replace? We need to replace, if we're reversing our directions, every right turn is going to become a left turn, and begin so the first instruction is going to say begin. So there's a special case here, right? The special case is that we have to do something special for the first instruction. So what we can do here is just do it for the first instruction. And again, this is the first version of our solution. We can make it more elegant as we go, but we want to first get it working. And in fact, before we even do that, let's return rev, because we want to run the tests first. So we haven't done everything we need to do, but we're going to, right from here, we're going to just return the list we've made just to see what the test status looks like. So we actually passed one of the tests. Not sure how, but we failed the other ones because you can see kind of, right, that we haven't totally done this. Okay. Okay, so let's go ahead and replace for the first one. And it returns a copy, replace does, meaning that we can't really change it in place. Now, we could do something like with list. into, so for example, if I wanted to take, so if I wanted to x.insert index, then the value. So if I want to insert 0 at index 0, so I can throw things in there. So I can actually insert, but I can't really replace, right? So it's a little bit funky that way. What I prefer to do, I don't like messing with lists in place because I think it's messy. So instead, what I'm going to do is I'm going to create a new list called res, or result, and make it an empty list here. And we can do this to start. So for example, res.append, this is kind of cool. The first instruction from the reverse list, but we're going to replace what are we going to do? We're going to replace left with begin. But what if it was a right turn? Turns out we can chain the replaces. There's another way of doing this a little bit cleaner, but this is fun for now. So we're taking the first instruction and we're replacing any occurrence of left with the word begin, and just in case it was a right turn, we're replacing right with begin as well. And so that string gets reversed. That string gets appended to our result list. Then we can do for, let's go through the rest of the list, right? So for r in rev, so our reverse list, right? And let's go through starting from index 1. Because remember, we can slice an slice a list this way. Going back to our REPL, we can do x1, right? And it only starts at index 1 and gives us the rest of the list. So we already took care of the first instruction. We don't care about that one anymore. We need to handle the rest. So for all the rest of them, what are we going to do? Res.append. So we're appending the result. R.replace. So we have a tricky part here, because if we replace left with right, we do the same kind of chaining we did up here. We replace left with right, and then we do replace right with left. Everything is going to be a left turn. So we can try this. We can do if left in R we do this replacement, else res.append r.replace right with left. And then instead of returning the reversed list, we're going to return the result list. Let's see how that goes. All right, what did I get wrong? So it tells us here that this, what we got, this is what we gave it as a result, should equal, and so this is what it should have been, so we can see what the difference is. So let's see. Begin on 9th drive. Good so far. and then it says left on first road. Oh, interesting. Right. Because begin is in there too, right? Begin is now at the very end of the list. Begin left. So begin right left should become begin. Wait, what? Well, let's comment just this out. See what it's doing here. So I've commented out the replacement code. We'll just put in the result plain. Begin right, begin right. So then we just have to replace begin right, right. Oh, it's interesting. So you don't change the first. Right. This was this one's a little bit trickier than I thought it was, because of how directions work. Right. If you so if you begin, then you go left, then you go right, then you go right, then you go left. Right. So then stop that. Then, so to reverse it, right, you have to begin wherever you are, right? You kind of began there, and then the next one is reversed. If this is painful for you, I apologize. Directionality is I'm like good at maps, but this kind of sequential stuff is a challenge for me. And it's probably not helping you at the moment either. So let's go ahead and try a different one, right? Try another kata. Well, I can come back to that one. You can come back to any of them that you want. You can star them for coming back later. Maybe a sort numbers. Find the solution so that it sorts the passed an array of numbers that the function passes in an empty array. Then it should return an empty array. All right, let's do this one. Okay. This is about a particular concept in Python, where you want to understand how sorting works. Sorting is something that Python can do built in. So, you can look up Python sort in your documentation. So there's a whole section on sorting, and you can see here that there's actually a built-in sorted function that works most of the time. So we'll give it a shot here if it's a simple list. So we should say return sorted nums. Okay, cool. Attempt. So we passed the test, but then it says none type object is not iterable. So we can do this a couple of ways, right? Remember that default parameters trick we did before? Let's give it an empty list, which is what we're supposed to return if it's No, that won't work, because if it gives it none, then it's none, not an empty list, right? So if I run this test, it won't. Okay, I guess it is going to pass because none counts as nothing. Python idiosyncrasies. So that passed. Let's give it the full attempt to see if that works. Yeah, see, none type is not iterable. So I was right. The test was just confusing. So this isn't going to work in our case because none is being passed. So it's not that we're not passing an argument to the solution. It's passing the none type. Now, we saw a trick before where we could use an OR to guard against that. Why does that work? Because the none type doesn't equal false, but it also doesn't equal true. So it's kind of, none is a really weird animal here. So if I were to say like none or 1, it gives me back 1. Because none doesn't evaluate to true. It's a little bit weird, but I can use this fact about the none type to pass this test elegantly. So I could say return nums or the empty list. And you see here now I actually pass all the tests because I'm handling both somebody not giving me an argument, or they're giving me a none type. And you can see it's very similar to solutions that other folks have done. Okay. Before we go over to the next resource that I wanted to share with you, Code Wars is cool. It's not the only one. Before we go over to the next one, I wanted to talk a little bit about methodology here. So first of all, start small. Try those trainings. I'm really sorry that I was getting so flustered by the directionality one. That's not so much about programming it as just like thinking about how directions work. And sometimes that's going to be true, right? The problem isn't going to be even the code. It's going to be the nature of the problem itself, and how you mess with it. Now, the other thing about Code Wars that I want to encourage you to do at the start is read the answers, and including skipping the problem if you have to. What do I mean? If you're really struggling with a problem, like I was with that one prior, it's okay to skip it and read the answers, because guess what? You're going to learn from the answers. This isn't a test. Nobody's grading you. Learn how you need to learn. And I will tell you that I learned a bunch from reading other people's work, because they know how to do it. I don't know how to do it yet. So if I can solve the problem, that's great. That means that I have figured that part out, and then I can look at the answers and see how others have done it and improve. But if I just can't get there, it is absolutely okay for me to go look and see how it's done. It's not cheating. That's not a thing. You can look at the answers in this case. So I encourage you to do so. That might help you. If you're looking for a little bit more of an exciting approach to learning programming, something a little bit more visually appealing, especially if you want to do it, with your kids, or if you are a kid and you just like the stuff we've been looking at is super boring to you, Code and Game. Let's take a look at Code and Game and see what it has to offer for us. All right, later Code Wars. We're going to go over to Code and Game, if I can type it. Okay, so Code and Game is a very similar approach in that there are going to be tests to pass. And I have logged in here previously, so but you can set up an account very similarly. I think it's got Google login enabled. I also think there's a GitHub integration. So same deal, you're going to want a GitHub account. And so let's take a look at how Code and Game works. Let's go through the introduction again. So you're going to learn how the puzzles work. And you can see that it's like, you're going to shoot some enemies with your ship, right? So you have to make the game work. So let's click on solve it, and let's actually go through. So it has a very similar interface, right? Except that you're going to have a game view up in the top left. And you have your instructions here, what you need to do. And then you have to solve it in your language of choice. This was one of the first ones to use the Rust programming language. If you haven't figured it out, I have a thing for the Rust language. But it has Python now, and it's pretty cool. So now it's time to code. It's making us copy and paste this code into the right place. I think that sucks. We should have just been able to solve it. But so we're going to say, so it's looking at enemies, right? And it wants to shoot the closest enemy. That's the objective here. So it's getting the enemy. And what we have to do is, so we're getting the enemies, we're getting the distances, and then we have to decide which enemy to shoot with print statements, I guess. So if dist1 is less than dist2, then we're going to do enemy 1, otherwise print enemy 2. We now know that there's a more elegant way to do this, and we're going to do that now that it lets us. But so once we put in that code, let's check the code. We're going to play the test case. And then off it goes, right? It fires this off. Okay. I don't want to submit the code yet, though, because I want to do this a little bit better. So can we do this in one line? We can. So we're going to print enemy 1 if dist1 is less than dist2, else print enemy 2. So this is a fun new thing that we've learned in our syntax. Let's unindent that. If it's a short enough conditional, let's make sure that still works. Yep, still works. If it's a short enough conditional, you can do it on one line. Kind of a nice thing to know. So let's go ahead and play all the test cases. There's only one in this case, but there may be others. And let's go ahead and hit submit. Cool, I leveled up. Okay, so they're going to be ads. That's kind of how that goes. A lot of these are provided by companies that are essentially looking to recruit programmers, right? So if you prove yourself worthy, you might get notifications like that. Let's go back home. Am I a professional coder? Kind of. I guess I am now, yeah. Go away. So now that we've done that, we can kind of move forward. So go to practice, and there are all sorts of puzzles. Batman related, copyright DC Comics. Thor, copyright Marvel Comics. We play a bunch of these, right? So here's a good one in loops. And if we go to solve it, let's see. Destroy the mountains before your starship collides with them. For that, shoot the highest mountain on your path. And again, so we're kind of using print statements to provide the value. Oh, this is Star Trek. Cool. You're using print statements to provide the information back to the test. And we're getting the value from input. So height of one mountain is when we get the integer from reading text in. So the while loop represents the game. We've done that in our rock, paper, scissors game, right? While true. Each iteration represents a turn of the game where you are given inputs and where you have to print an output, the index of the mountains to fire on. So let's see here. For I in range 8, so we're going through integers 0 through 7. And let's run the game just to see what happens here. Descending mountains. So we print 4. And our objective is, for that, shoot the highest mountain on your path. So we have to shoot the highest mountain on our path, whatever that one happens to be. At the start of each game, you are given the height of the 8 mountains from left to right. Let's take a look at what those heights are just by printing them out. I haven't done this before, so let's see. Your code did not read all available inputs. That's fine. So it says height of mountain 0, 9, 8, 7, 6. So they're going descending, right? So what we need to do is determine what the tallest mountain is. I see. So essentially we're going through the loop and we're getting all of them, but we're at the very end, right? Outside of the for loop, we have to print like the answer to whichever one was the tallest. Okay. Well, there are a bunch of ways to do this, but the way that I want to do it is by introducing the max built in Python. So remember this X we have here? We have a built-in max function that will go through a sequence and tell us what the largest number is. That's great because if we need to shoot the tallest mountain every time, all we have to do in this case is make a list. So mountains equals empty list. It's going through all the mountains, right? And giving us the heights. So we're going to do mountains dot append mountain h. And then what are we printing? We're going to print the max value for mountains. Let's try that. What? Oh. I see. So we can't, right, we have to give the integer, the index. So let's do this another way. Let's keep track of the tallest. So we'll keep the mountains, right? Let's see if there's a better way to do this. I want to keep track of all the mountains because I want to compare their heights. Oh, wait, yeah, here's a great way to do it. So we need to keep track of two things. We need to keep track of the index of the mountain and the height of it. So, but we only need to keep track of the tallest. So So we're going to say the tallest mountain is initialized to index 0 and a height of 0. Now we're going to get the mountain h. So we're going to compare now. We're going to say if mountain h is greater than tallest mountain, and we're looking at the height is the second value here, then we're going to modify it. We're going to change tallest mountain. So tallest mountain equals, and the index is going to be I, and then the height is going to be mountain h. So we're running through, we're checking for each one, and then finally we should be able to print tallest mountain, the index. That's what we want, not the height. That should be square braces. Oh, thank God. Again, I have not done these before, so this is I'm doing these live. All right, so check it out. It's going through, and for each one, it's shooting the tallest mountain. And this should work for pretty much all of them. Let's play all the test cases. Looks like we got it. Cool. And I leveled up, I guess. Okay. So Code and Game is great if you are interested in kind of a more game-based approach to the programming exercises. I find their instructions slightly less clear than the ones in Code Wars, and I you know, that's just kind of not my thing as much as the Code Wars stuff. But I do think it's valuable, especially if you want kind of that extra flavor of what's going on and using the context of games to understand programming. I've saved my favorite one for last, and this will be a shorter session than other days we've had. But I've saved my favorite one for last. But this is also the most involved to set up, so fair warning. But I think it's worth it. That is Exorcism. Now, Exorcism, I'm going to tell you, absolutely is the tool that took me from being like an okay programmer to a solid programmer with a deep understanding of the really elegant ways of doing things in a lot of programming languages. Exorcism was how that worked, and Exorcism has changed a lot since I started using it. So let's take a look at Exorcism, and then we can talk a little bit about how to set it up, both on your personal computer, and even if you need to, you can use Replit to do it, but that's a little bit trickier. So let's take a look at Exorcism. Okay. See you later, Code and Game. So exorcism.io is where Exorcism is. Go away. So you can sign up with for Exorcism with GitHub, sort of the same thing as we've done with the other resources. And as you can see, it too has a bunch of different tracks for different programming languages. It has Racket. Racket might be, yeah, Racket's definitely in my top 3 programming languages. What's cool about Exorcism, a couple things. First, each of the tracks uses the same exercises, very similar to the way that Code Wars works. And what you might like to do is, as you're ready, once you're done learning, never done learning, but once you're comfortable using one programming language, you can go back and do the exercises in another programming language. And I'm going to tell you that the second programming language is way easier to learn than the first, because you have this connection, this relationship mentally. And well, Piaget called them learning schema, but you have this thing that you can connect new knowledge to. Okay, so if you look at how Python works, there are these exercises, right? like hello world. But if you talk about how, let's talk about how you set it up, because it's a little bit tricky to set up. Exorcism is a command line program. It's a command line piece of software. So you actually have to install Exorcism somewhere. And if you go to Hello World, you click Begin Walkthrough, it'll tell you how to do it. So, you know, you choose which OS do you use. I guess it's alphabetical, but nevertheless, I appreciate them putting Linux up on top. But if you're on Mac, if you're on Windows, it'll tell you how to install Exorcism. And if you want to go do that, you can walk through doing it this way. I'm going to show you how to actually install it on Replit, because you can do that. Let's go ahead and make a new REPL. I'm going to make a new bash REPL. Okay. So the first thing we need to do in the bash REPL, let's go ahead and type bash to get our full shell. And the first thing we need to do is download the Exorcism application. And to do that, click on Linux for which OS do you use, and click Use the Source Code. And this is where GitHub comes in handy, because the source code for the program is installed, or is hosted on GitHub. So go ahead and click Releases, and that will open up a tab for the Exorcism command line interface, CLI, which we've seen before. Now, what we want to do here to install this on Replit is go down to find the x86_64.tar.gz. That's the one we want. How do we know that's the one we want? Well, if we go over to our Replit and we ask the computer for what kind of an operating system it is, it tells us that it's Linux, and it tells us that it's an x86 processor, 64-bit processor. So that's how we know. So we want the x86 64 package. So what we're going to do is we're going to right click on that. We're going to copy the link address. Over in Replit, we have a tool that downloads stuff, so called wget. So you do wget and then the address, and it goes and downloads the thing. Pretty cool, right? If I ls now, which we've done before, you can see that I have that tar.gz. If you haven't seen tarballs before, they're like zip files. Okay, they're a compressed file format. So we have to extract it. The way that we do that is we can use tar. It's a built-in program on our bash shell. Tar and then x, was it gz? Yeah. So tar, let's do xf, and then exorcism, and I used the tab to type all that, ex and then tab. Look at the things that got made. See that? And you can see that exorcism is a program because it's green. So if I type /exorcism, you can see that it runs, right? Look at that. So I have to configure it. And how do I configure it? Click continue here. You can do this if you want, but we can run everything as is from here. So you can follow these instructions to put exorcism in the right place. Let's do it the right way. So it's asking us to make a bin folder in our home folder. See that bin folder? And then mv exorcism to bin. Okay. And then what did it ask us to do next? Let's confirm that it works from there. It does. And then I don't think this is necessary because the replet's going to change every time. But if you want to add it to the path so that you can run it just with the command exorcism, you can do. I would put this in main.sh actually, but for replet. But what we're basically saying is we're changing the path where the operating system looks for programs. If I look for path, you can kind of see these are the places it looks. So I can say like export path equals path, and then with the colon and then the tilde/bin, I can tell it to look there too. See, now it's going to look in those places as well. So now if I just type exorcism, it runs. So that's kind of what we're doing. You don't have to do that. You can run it right from the folder you had it in with /exorcism. That works fine too. Okay, but now that we've done all that, we have to configure it. This is my token. Do me a favor and don't don't use this one. Did I successfully copy that? Nope. So once you configure it, go through this. Yes, continue. Yes, yes. Configure the CLI. And you can find your token on the settings page. Settings. Put that in there. Okay, so now we're ready to actually do stuff. If I go to exorcism, so if I wanted to do the hello world exercise, finally, let's take a look at what we're doing here. The classical introductory exercise. It tells you how to run the tests. It runs tests just like we do tests in Code Wars, but we do it on the command line. So if I run this command, it'll download the exercise. So I can copy this right here, go over to my replet and paste that in. Okay, so if you see, I've got an exorcism folder. So if I go to exorcism, good Lord. And go into my Python track, you'll see that there's a hello world. Now, this isn't going to show up by default over here on the left-hand side because it's not looking in the default folder for replet. We can configure it to do so. But for now, we're going to stay in the command line, which means pretty much just look at this. So there's hello world.py. If I cat that out, sorry, .py, you can see that there's not a lot in there. If I cat hello world test.py, you can see these are the tests that need to pass. And then if we go back and look at the exorcism instructions, it tells us how to run the test. It says run pytest hello world test.py or python-m pytest hello world test.py. Let's try, let's see if pytest is actually recognized. It's not. So let's try the Python using the module pytest and see if that works. Yeah, so it says no module named PyTest, but that's easy enough to fix with pip install PyTest. So if you're interested in using Replit for exorcism, what I'll do is I'm going to, and check out my Twitter for this, I'm going to set up a template for exorcism correctly so that you can use that REPL and fork it for your own purposes. So keep an eye out for that. But now we should be able to run the tests. Yep, we can. So we ran the tests using the instructions provided by exorcism, and it tells us that the test failed. Why? Because none does not equal hello world. Well, let's fix that. So I'm going to fix this using the built-in text editor in the terminal. But again, we're going to configure exorcism for our real Replit to use the built-in, the Replit text editor. Okay, so here's hello. It should return hello world. And if you think that it's really cool that I can enter a text editor directly from the terminal, you're correct. It is cool. Oh God, can I exit it? Yes. At some point, we'll talk about Vim. I've stopped myself from talking about Vim because it's a rabbit hole for me. I can talk about Vim all day. Okay, so now let's run those tests again. And they passed. And guess what? I can submit right from here. If I go look at my instructions, I can do exorcism submit and then just the path to the file. So I can do exorcism submit hello world.py. And it says your solution is submitted successfully. You can complete the exercise and unlock the next core exercise at whatever. And then if I go over to exorcism here, reload it, kaboom, it is solved. And I can either complete the solution. This is cool. I can request mentor feedback or view community solutions. So very similar to Code Wars, I can go see how other people have solved it. Really, really important. This right here is the secret sauce to exorcism, where looking at how other people solve problems in code allows me to, allowed me to become better as a programmer because I was taking advantage of their expertise. Complete the solution, and then we can move on to the next one. We can publish my solution. This is where, again, you're sharing with the community and allow others to comment. This can actually be helpful. The exorcism community is pretty kind. So a lot of people will just give you helpful hints on how to make your solution better. I recommend giving this a shot. It is not, it's not the same kind of environment you might have experienced elsewhere on the internet. Okay, and then from there, you go back to your Python track and you choose a different exercise. All right, so that does it for exorcism and the 3 resources that we were going to explore today. I hope some of these have seemed interesting to you and you want to get started using them. As I said, for exorcism, because it's kind of involved in the setup, what I will do is I will create a REPL that you can fork, meaning make a copy for yourself, so that you can configure it and get started using exorcism on your own. Now, so that's kind of where we are right now. We're building up that muscle memory for programming and getting the basic concepts into our hands so that we don't have to think about them so much moving forward into more complex issues. And so this isn't the only way to practice. I think most people, once they get some handle on programming, they want to build their own things. And there are lots of ways to find inspiration for how to build things, but first you need to be confident enough in your ability to do so. Just like, writing a song, right? You have to be able to play music proficiently before you can do so. So that's kind of where we are. We're still learning the scales, reciting other people's music, right? And then soon we will be able to improvise. And we're going to start to go a little bit deeper into a full application next time. Sorry, just kidding. No, we're not. We're going to take a moment back and talk a little bit about networking next time, before we dive into our big project to end the course. Okay, so that does it for this week. Thank you all for sticking around. If you're liking what you're seeing and you feel like giving back, I encourage you to donate not to me, but to Human IT. They are an organization providing low-cost internet connection and computing devices to families in need. We're getting to the beginning of the school year here in the United States, and there is just report after report of families who are struggling because they don't have the devices that they need, and school districts that cannot provide them. So if you have any devices to donate, please do so if you can, or if you can contribute financially. Human IT and the students and families that they serve would really appreciate it. You can find them at human-i-t.org. And yeah, if you can give, I just encourage you to do so. So as I said, next week, we're going to dive a little bit into computer networking and how computers talk to each other so that we can have all of the bases covered for core concepts before we dive in to build our big application to round out the course. All right, that does it for this week. Thank you so much for sticking with us, and happy hacking.